So hey there, welcome back to another video of Space Technology YouTube channel. And in this particular video, I'll be reviewing another article on IEEE spectrum. But yes, the main topic of this one is one way that could improve space-based power. So in this particular video, we'll be talking about another space technology related topic that is again on the same side, that is IEEE spectrum. And you can refer to this site. I'm just reading out that particular article for you guys, so you can get the audiobook, like audio of this particular article. So yes, let's get started. If you haven't subscribed to the YouTube channel, make sure to subscribe for other space technology related ventures and stuff that will be surely uploaded on this channel. So one way that could improve space-based power relays. Intermediate transmitters could more effectively beam power to on the ground. So this is the main thing. This article has been written by uh, the name of the article, Michelle Hampson, 7 November 2024, 3-minute read. But let's say how we get into that. Anyways, this article is part of her free exclusive IEEE Journal Watch series in partnership with IEEE Explore. As part of the ongoing search for more sustainable energy solutions, some researchers are thinking outside of the box or globe really. One team in California is proposing a new transmitter array system that could help harvest energy directly from space through prototype tests on smaller earthly scales. They demonstrate how the proposed system can more than double the amount of power transferred between power harvesters and receivers or extend the range by a similar factor. The concept of harvesting energy from a space-borne solar array and beaming it to Earth's surface was first proposed in the 1940s as science fiction, but the idea has sparked interest among scientists, prompting them to explore its real-world feasibility. Whereas wind and solar energy harvested on Earth is dependent on weather conditions, harvesting energy directly from space would theoretically provide a more consistent supply of energy. But the approach comes with some obvious challenges, including successfully directing and refocusing the power beam microwave frequencies, in this case, in the desired direction across such vast distances. Very large transmitters in space and receivers on Earth would be necessary to pick up the power signals, which would inevitably disperse over such long transmission distance. To address this issue, Ali Hajmiri, a professor at the California Institute of Technology, and his colleagues are exploring the possibility of an intermediate system of a programmable transmit array that orbits Earth at an altitude between the space-based transmitters and the Earth-based receivers. Such an relay approach would give scientists more control over where the beam is directed on Earth's surface and ensuring more power successfully find its target. Alternatively, it would allow for smarter transmitters and receivers. Programmable transmit arrays placed in some intermediate orbit can alleviate the size requirement greatly by focusing the beam, allowing for use of smaller transmitter and receiver systems, says Ajmeri. The researchers describe their proposed transmitter array system in the study published to October in IEEE Journal of Microwaves. The system is constellation of equally spaced transmitterary antennas occupying the same orbit. As one transmitterary moves away from the other. So, harvesting array system in space called the active array, a second transmit ready would approach and take over relaying the power of Earth as the first one moves out of range. In their study, the researchers designed and tested several low cost, lightweight proof of concept transmit arrays to refocus the beam. Finding the tactic could transfer nearly 2.5 times as much power as a system that would beam power straight to the Earth. The experiment involved a small proof of concept prototype with power transmitter and receiver 3.8-meter apart in the anechoic chamber, or it's the chamber. I don't exactly know how to pronounce that, but yes, the power boost means the systems could work across greater distances or require smaller transmitter and receivers for a given distance. Hajmeri notes that while the implementation of this intermediate array would increase the overall cost of the system, the increased energy yield would make the system more cost effective per unit of energy over its lifespan. While a fully functional space to earth power transmitter is still far in the future, Hajmeri and his colleagues plan to continue to develop and test their solutions. One of our areas of focus is building larger scale and more programmable transmitter arrays and test them in a space environment. So I guess that was it for this particular video. If you like the video, make sure to subscribe to the channel, and we'll meet in the next video with another topic that is related to aerospace technology. So that was it for this one. Thank you for watching.